actually. All right, so right here, oblique triangles and the law of sines. Now, law of sines. Huh? What about it? You need one? Okay. The homework one? Yeah. Who's passing out the homework?
Be him.
It was Narwhal.
No, it was Herman.
No, it was Herman. Narwhal was passing out.
It was Herman. That's why he's so silent.
Okay. Anyway,
No, it was Herman.
where's the rest of the pile? Where'd the rest of the pile go?
It's underneath the home.
Oh, it's right here?
It's underneath.
Okay.
Yeah.
Sorry.
Be him, Andrew. Be him.
There we go. Okay, so this is actually super important. It's one of those things that you're actually going to use. A lot of times when you're doing triangles, you're not going to have a right triangle. Majority of the time, you're not having right triangles. But there's laws and stuff that go along with this. All right, so for this to work out, congruent axioms is side angle side. That means that the angle is where?
So, on the side.
Nope, try again. Huh? Corner is a triangle. Triangle has 3 corners.
In the angles.
Bottom.
Say it. Between the 2 sides, right? So if the angle is touching between the 2 sides, that's side, angle, side. So the angle is between the 2 sides. That's pretty straightforward, right? Okay. So for the congruence, that has to work. So you have to check both of them. Same thing here. So angle, side, angle. Where's the side have to be? Between the 2 angles. So it's touching both those angles, right? Side, side, side.
All sides.
All sides.
Like a side cheek, all sides.
There we go.
It's
Oblique triangle. Triangle that is not right. Measure of 3 sides of measures of the 3 sides and the 3 angles of triangle can be found if at least one side and any other 2 measurements are known. One side and 2 other measurements. So, if I have 3 sides, will that work?
No.
Say yes.
Yes.
Okay, what about one side and 2 angles?
Yeah.
Yeah.
Yes. Does it have at least one side?
Yeah.
At least one side. What if I have 3 angles?
No.
no.
No. Okay, we can solve it if you have at least one side. Go. All right. Solving. Blah 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 blah. Oh, do you know what? Let's just go with this. Anyway. Okay. We know that 3 angles of a triangle we cannot find. If we know 3 angles of a triangle, we cannot find unique side lengths for this, since it's angle, 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 and it's similarity, not congruence. That's what I'm just saying. If you have 3 angles, you can't find it. Okay, so for the law of sines, let's take a look. So start with an oblique triangle, either acute or obtuse. Okay, and right here. And C is the hypotenuse of the right triangle. So we have right here. So we're trying to actually find the different sides of what we have here. So, you know what, let me just go to directly. That's the law, and I'm going to go directly to here. There it is. The rest is blah, blah, blahs. All right, so what does the little letter stand for? Sides. The big letter stands for? Okay. Little letter sides, big letters angles. All right, let's see. Solve the triangle here. If I know this. Do I have at least one side?
Yes.
Okay, so now I need to have corresponding sides. That means I need to have a big and little of the same thing. Do I have that?
Yes.
Yes. What do I have big and little of?
A.
A. I have big and little a, right?
Yes.
Yeah.
I have big and little a, so that's important. So big and little a, that's a start. And now I could actually use it to solve the others. Okay, so solve the triangle. That means I need to find everything else. So given this, so I have big and little a. So it's going to write that as over sine of degrees, right? Equals. There's a ratio. There's a ratio. So what am I going to? What other information do I have?
Little b over big. Or the
Little
big
b over.
I have big B, right?
Yeah.
If I have big B,
So x over.
I can solve for little b.
Little
So I have that, and so I'm going to solve for little b now, because in my cross products, my ratios, my proportions, I am only going to have one unknown. If I have two unknowns, I can't do this. So my only one that I have is going to be little b, right?
Right.
Yes, thank you. Now, it's called cross products. Product means multiply, cross means, yeah. Okay, so let's do that. So it's going to be b times sine of 32 degrees is equal to 42.9 times sine of 81.8 degrees. I'm trying to solve for what? B. Trying to solve for B. So what am I have to do to get B by itself?
Divide by sine.
Very good. So I'm going to divide by sine 32. Very good. So what am I plugging in my calculator? That. And when you pick up the calculator, what do you have to do?
Make sure it's in the right setting thing.
This one's in degrees, right? And clearing it is a very, very good thing. Yes. Huh?
I'm telling 5 dollars. 109. Did it say to get 109? Yeah.
Yeah, it was like that.
Not for the sign.
You have to put it in
Yeah,
the
I
sign.
think
Why?
Because you're multiplying it by sine.
Guys, it equals 80.170.
You're divided by sine.
You didn't get that wrong. When you divide it by a sign, you don't need to do it. When you multiply it,
Have we learned this in like past years or
Nope.
something? Because I feel like we have.
So you should get what he has.
we did triangles last year.
I don't think you did law of sine and
But
cosine.
it has the sine thing in it. So that's
Yeah.
the only new thing. Okay.
8.1.
What do we get? So little b is about 80.1 cm. Thank you. All right. What else do I need to find?
C. Little c.
Little c and big C. Now, can I solve for big C real easy?
Yeah.
All three angles in a triangle add up to?
180.
Very good. So big C. Do the math, please.
It is 66.2.
6.6.
6.2.
So 6.2 degrees. That's big C, right?
Yeah.
Okay. So now, can we solve for little c now?
Yes.
Let's do the same thing. So what am I going to start off with?
We're going to start off with the
First
A.
of all,
The A's, right?
Yeah,
Why am I starting off with the A's?
because that's next to the other side.
That's given to us.
That's given to us.
That's given to you. You want to use what's given to you first. Because what if I made a mistake on the B? That would mean my C's would be wrong, wouldn't it?
oh yeah. When you put it like that, you.
Okay. So, does that make sense? So, we're starting with what's given to us. and then we go from there. So I'm going to start with the 42.9 over sine 32. Let me see. 42.9 over sine of, what was it?
66.
32 degrees, right?
Wait, yeah, so 32.
Equals. So it's going to be little c over sine of 66.2 degrees. Was that what it was?
Yeah.
Okay, big C was that, right?
$74.1. Well, it might just be 74, but. Are we going to the nearest?
10. You just go 10.
Okay, so that's 0.74.1.
What is- 74.1. What are my units?
Centimeters.
And why do I know I'm going 0.1? There's a good reason right here.
It's only
Because this other one's going to 0.1, right? The other one's rounding to 0.1, and centimeters are already there, right?
Yes.
Super easy, right?
I think we can do the homework.
And
Pretty close. Almost.
we have to also check with B to see if we got B right,
What do you mean? No, you don't have to because we got them all. All right, is there a question over there?
Big C or little C?
Hey, did you get it?
No, I'm just stretching.
Oh, okay. So we got little c. Let's see. So we were missing little c. We got little c. We were missing little b. Got little b. Got big C, right? There we go. That's everything. So here's a hint. How many sides does a triangle have?
3.
How many angles does it have?
3.
If I need 3 things just to start this, how many things to solve the triangle?
3.
You need to find 3 more things, right?
3 and 3 on 3.
So that's a good thing. Because when you're checking your work and you want to make sure all your work is right, oh, did I solve for all of them? Oh, look, I got 3 things. I'm still missing 3. There we go. Okay, so right here. Whenever possible, use given values in solving triangles rather than values obtained. Intermediate steps to avoid possible rounding errors. All right, Kurt Daniels wishes to measure the distance across the Gadsden River. Gascon or Gascon? I don't know.
Gascon.
I love stuff that every single day.
Okay. So he determines that big C is 112.90 degrees. All right. Big A, 31.10, and little b is 347.6. Find distance A. So that's going to be little a, right? Okay, so let's see. I'm looking for little a. I'm looking for little a, right?
Yeah.
Do I have big A?
Yes.
Okay. I have little b.
You don't have big B.
Okay, I have little b. Do I have big B? No, I don't. So let's take a look. Do I have big C?
Yes.
So, given 2 angles, can I find the third to find out what big B is?
You can immediately just do it.
Yes, do it. Do the math, please.
26.
Oh, yeah.
Did you do the math or just read it on the paper?
Why do I keep putting time?
So we get what?
36.
36. Okay, so now let's set up my ratio. So start with what I know. So it's going to be,
36.
no, little b, right?
Oh, yeah.
347.6 over sine of 36 is equal to, now remember, what goes on top here?
A.
Little a, right? Little a.
Lily.
So it's little a
Lily.
over sine of 31.10 degrees, right? Cross products. So so it's going to be a times sine of 36 is equal to 347.6 times sine of 314. And then divide both sides by sine of 36. Divide by sine of 36. So A should be
305.
305, what?
305.5.
And what are my units?
Feet.
There we go. Now, does that make sense?
Yes.
Kind of what we've done already.
Yeah. It's a lot of what we've done already, right?
Yeah, this is all stuff pretty much just minus
This
the
is
side.
basically
Yep.
just review.
I'm telling you, this is a lot of stuff. So the way that I'm teaching it is that it keeps building on itself. It's the same thing over and over again. So you feel more confident every single time that we do it and we redo it. Make sense? All right. So, okay. I'm gonna stop right there. We're gonna finish this on. Yeah, we'll finish this tomorrow.
Hey, so are we back to moving fast paced through the rest of the lessons now?
Kinda.